A plus A transpose plus half into A minus A transpose. So these are some of the square matrix of symmetric and skew symmetric. We can any part of the you have giving to the one square matrix, we can write into the part of the symmetric matrix means we can write into the half into A minus A transpose. Civil 27. What happened, ma? Hello. Rule number 27. Civil. Hello.
Sir, 26 present, sir.
రుద్వేష్ ఇంతకుముందు ఏదో హ్యాండ్ రైజ్ చేశారు, ఏమైనా డౌటా? Okay, ma. So if find the part of this symmetric matrix means we can write into half into A plus A transpose. You find this part, we can write into the symmetric matrix of the real matrix. And next skew symmetric also we can any part of the skew symmetric means half into A minus A transpose. This we have to find out, we can write into the symmetric and skew symmetric. If any matrix is said that is a symmetric or skew symmetric, we check the condition. What is the symmetric definition is that if any square matrix is said to be symmetric, that is A is equal to A transpose. A is equal to A transpose. This condition is satisfied, that matrix will be called as a symmetric matrix. And next, skew symmetric matrix. If any matrix is given, you find the skew symmetric matrix, right? A is equal to A minus A transpose. So this is a condition for the is checking for as a symmetric or skew symmetric, this one, and is a part of the any square matrix. So we can find out A plus A transpose or half into A minus A transpose. So this is a we have the finding. Next, orthogonal of matrix. Orthogonal of matrix is nothing but you can write into the a square matrix is said to be orthogonal is satisfying to A is equal to A, sorry, we can write into the A into A transpose or A transpose into A is equal to I, is a unit matrix. That is called as a orthogonality of the matrix. This is a we have learning in the module 1. And also you can another one is learning in module 1, complex matrices. Complex matrices. Complex matrices. So complex matrices is nothing but we have the in a matrix is a numbers or elements is having to the A plus IB or A minus IB, or you can somebody you can say into the complex numbers. The elements are complex numbers. We can arrangement of the rows and columns. That is called as a complex matrix. The complex matrix we can writing to the if have the writing to Hermitian and skew Hermitian. In before we can writing to the conjugative of matrices. Conjugate of complex matrix. Complex matrix is nothing but we can write into the is a any complex part is writing to the real part and imaginary part. The imaginary parts before sign is the changed, as a plus is there, minus is there, is writing to the plus. So that matrices we can call it as changing of the matrices, we can call it as a conjugative of the complex matrices. And next here the conjugative complex matrices, the transpose means we can write into the complex matrix, we can write the conjugative of complex matrices. After that you can apply into the transpose means is interchanging into the rows and columns. That is called as a transpose of conjugative of the complex matrix. This is denoted by the A power of theta. That means is a conjugative of complex matrix is denoted by the A bar. So A bar whole power of T is called as a conjugative transpose of matrices, A power of theta. So here we have the real matrices, which like only have to learn the same like we have here learning into the Hermitian matrix. Hermitian matrix. Okay, is a matrix. Is a matrix is said to be Hermitian. It is a complex matrices, and they're satisfying into the A power of theta. A power of theta is nothing but transpose of conjugative matrix is equal to A, is called as a Hermitian matrix. And skew Hermitian. Skew Hermitian is nothing but skew Hermitian. Skew Hermitian is nothing but we can writing to the if any complex matrix is said to be skew Hermitian, it is satisfying to the condition A power of theta is equal to minus A. Or some cases we can writing to the A is equal to minus A power of theta. So these conditions will be satisfied. That matrix is called as a skew Hermitian matrix. So, and the same like we have the writing to any square matrix, the sum of the symmetric and skew symmetric matrices. Here also writing to the any square matrix, the sum of the A is equal to half into Hermitian matrix. Hermitian matrix is nothing but A plus A power of theta plus in the skew Hermitian matrix half into A minus A power of theta. So this is a Hermitian and skew Hermitian matrices. The part we'll be writing the same like we have the writing to the here, writing to there. And another topic you learn here, unitary matrix. Unitary matrix. Okay, what is a unitary matrix is nothing but if any matrix is said to be unitary, they're satisfying into the A power of theta into A is equal to I, or A into A power of theta is equal to I. This matrix will be called as a unitary matrix. Is a unitary matrix. So, and also you have the, this is a you learning in the symmetric and complex real and complex matrices. Their applications you learning into the first one is inversion matrix. Inversion matrix. With the help of the you can writing to the inverse of matrices Gauss-Jordan method. Gauss-Jordan method. Okay, and also we can writing to the next one is finding to the topic is inverse of matrices. Inverse of matrices with the help of the Gauss-Jordan method, and this we have the learning into finding to the inverse of matrices like Gauss elimination method. A is equal to I into A means echelon form. Rank of the matrices. In this module also you learn rank of matrix. This is a major topic in this rank of matrices. The rank of matrices with the help of you already you learn the determinant of matrices. If that is not equal to 0, their order means their order we can consider as the rank of the matrix. The same like, but here with the help of elementary operations like row operations and column operations. Here the row and column operations is nothing but we can mostly we have the using you can writing to in this modules in this module we can writing to this elementary operations like addition or subtraction of the rows. The first one, the interchanging into the rows or columns, means the first row is the arrangement of second row and second row is arrangement of first row. Like we can arrangement of the rows interchanging. Next, if any row or any column is multiplying with some scalar value, some scalar value, with the help of the is multiplying with the either row and column is writing to there. So we can writing to in this type of problems will be writing. So the elementary operations like we have any row is multiplying with some constant and there writing multiplication and with the another row we can addition or subtracting. There we have the using is a rank of the matrices. Like we have the first one is with using echelon form. Echelon form. Echelon form of the matrices. Echelon form of the matrices is nothing but we have two types will be doing the row operations and column operation, but you learn only row operations, row echelon form. Okay, so in the row echelon form we can helping to the principal diagonal elements. You keep on the constants, the remaining, the below the elements is converted into zeros with the help of elementary operations. So the first row is a non-zero element. The second row we having the first zero is getting, the remaining elements are non-zeros. It's an increasing order. Zeros will be increasing order. So we have some cases. Some cases the entire row will be getting to the zero, or like some middle of the row also we can. Some cases we have getting to the zeros. So under that particular cases we have the interchanging into the rows and columns. After that you can set to be the rank of matrix is nothing but the number of non-zero rows. After elementary operations you writing the number of non-zero rows that matrix will be called as the in the form of the echelon form. So you can set to be rank of matrices the number of non-zero rows. The first model. The second model is with the normal form. Normal form. Okay. So normal form is writing to any matrix. If any order of the matrix with the help of row elementary operations and column operations simultaneously, either we have those completely we can do into the row operations. After that, we can do into the column operations. So, but no, don't confuse. We have simultaneously row operation and column operation and row operation, column operation. Like we have to do it there. So you convert it into the form of the unit matrices. Unit matrices. IR. Satya. Hello.
సార్ మీ వాయిస్ డబుల్ టైం వస్తుంది.
డబుల్ టైం వస్తుందా?
కొంచెం డిస్టర్బెన్స్ ఉంది. 2 times అట్లా రీసౌండ్ వస్తుంది.
వాయిస్ రీసౌండ్ వస్తుంది సార్.
నా దగ్గర ఏం లేదు నాన్న. నెట్
బాగా నుంచి వస్తుంది సార్, రీసౌండ్ వస్తుంది.
రీసౌండ్ వినిపిస్తుంది.
ఓకే. నెట్ అయితే బాగానే ఉంది. సరే.
ఇప్పటికి కూడా అంతే వస్తుంది సార్.
నెట్ అయితే బాగానే ఉంది నాన్న. ఏం డిస్టర్బెన్స్ ఏం లేదు ఇక్కడ.
మళ్ళీ అలానే వస్తుంది సార్, రీసౌండ్ వస్తుంది.
సార్ మీ రెండు అకౌంట్ల నుంచి మైక్ ఆన్ లోనే ఉంది సార్.
రెండిట్లలో ఉందా? వేరే వాళ్ళు ఏమైనా ఇదే అకౌంట్ లో
అయినా కూడా అలానే వస్తుంది సార్, మళ్ళీ రీసౌండ్ వస్తుంది.
ఓకే, ఈ రోజు అయితే కానివ్వండి. ఇంకొక 5 minutes అయితే క్లాస్ అయిపోతుంది కదా.
ఒకసారి మ్యూట్ చేసి అన్మ్యూట్ చేయండి సార్.
ఒక్క నిమిషం చేస్తాను. Hello. Now is getting to that voice clear?
సార్ మళ్ళీ అలానే వస్తుంది, రీసౌండ్ వస్తుంది.
అంతే ఉంది సార్, ఏం చేంజ్ లేదు.
మళ్ళీ జాయిన్ కాండి సార్.
ఉన్నది 10 నిమిషాలనా?
పర్లేదు సార్ చెప్పండి, ఏం కాదులేండి.
మనం ఆల్రెడీ డిస్కస్ చేసుకున్న టాపిక్స్ ఒకసారి రీకాల్ చేస్తున్నాను. రేపటి నుండి మనం క్లాస్ వెళ్దాం.
ఓకే సార్, ఓకే.
So you converted into the form of IR 0. You can write into IR 0, 0, 0. This form you converted in these three forms. If anyone say or another form is, you can write into this like IR 0. If any form you can get into that form will be called as the normal form. That form will be called as normal form. So this is a module 1. You learn in this rank of matrices with the using echelon form and normal form, and next one you can learn in the inversion method, Gauss-Jordan method. So that is A is equal to IA. This model we have right to in your previous first module you learn. Okay. So this is in the first module, and the second module you can go for this. Module 2. So in this module 2, you learn only eigenvalues, eigenvectors. So this is the eigenvalues and eigenvectors. So we have the writing to first any square matrix we can find into the eigenvalues. How we can find the eigenvalues is nothing but if any matrix in the form of A is equal to A minus lambda I is a characteristic polynomial. Here A is a given matrix, is a square matrix. I is also the same order of the same order of unit matrix. Is n by n is there, so you can write into the n by n. So this is the I by I matrix is writing to the same square matrix of the given matrices. You can write into the A is equal to A minus lambda I. Lambda is the scalar value. Lambda is scalar value, is a constant. So you can find this. We can write into the A minus lambda I. The det is equal to 0 is called as the characteristic equation of given square matrix. Lambda det of A minus lambda I is equal to 0. This we have called as the characteristic equation. Okay. We have the getting to the some values. The characteristic equation, their simplification, you get into the some values like lambda 1, lambda 2, lambda 3, like the same order of the this characteristic equation. So if you have the 3 is there, you can get into 3 roots. If you have into the 4 is there, you get into the 4 eigenvalues. If it is getting into the 2 is there, you can get into the 2 roots only. Like if how much order of characteristic equation is there, the same number of eigenvalues will be getting. This eigenvalues another name is a latent roots. Latent roots. Next, characteristic roots. Characteristic roots. And next, we can write into latent roots, characteristic roots. Next one, eigenvalues. eigenvalues. Okay. So we have the using into eigenvalues. They corresponding eigenvectors like A minus lambda I of x is equal to 0. So x is the unknown values. Is a given matrices. We have the number of unknown values. We can find the values. So some cases we can they're simplifying the A minus lambda I of x is equal to 0. The multiplication of x on this ax minus lambda xi is equal to 0. So we can this term we can send to this side. Ax is equal to lambda xi. Xi means we have the unit matrices. We can get into that x only. So that is Ax is equal to lambda x. Ax is equal to lambda x. So those cases, some cases we can write the corresponding eigenvector is equal to Ax is equal to lambda x. కొన్నిసార్లు వస్తూ ఉంటారు. So don't confuse. So we can the corresponding eigenvectors can get into the x is the column matrices. X is the unknown values. You can find the values with the help of eigen values. With the help of eigenvalues, you can write into their vectors will be right into the values will be right into independent or vectors are independent or dependent. We can write it there. So if you have the get into the their eigenvectors, their that is equal to 0. That is the linearly independent or dependent. Like we can write into the different cases. Is right into the 323. 323.
సార్ వాయిస్ డబుల్ వస్తుంది సార్.
వాయిస్ డబుల్ వస్తుంది. ఇప్పుడు నుండేనా చాలా సేపు
ఒక 10 minutes నుంచి వస్తుంది అనుకుంటా సార్. 10-15 minutes.
10 minutes నుంచి వస్తుంది సార్.
మేబీ చిన్న ప్రాబ్లం ఏమైందన్నా అది ఇక్కడ నాకైతే నెట్ అయితే బాగానే ఉంది. సో టెక్నికల్ ఇష్యూ ఉండొచ్చు, చూద్దాం.
సరే సార్.
ఒక 4 minutes అయితే అయిపోతుంది క్లాస్. మళ్ళీ రీలాగ్ కావాలి, మళ్ళీ టైం పడుతుంది.
ఓకే సార్. ఓకే సార్.
ఓకేనా? So here we writing to the is the eigenvectors like Ax is equal to lambda x, and next one we can write into eigenvectors. We can write in there. Their eigenvectors like x1 and x2, x3. So there are independent or dependent. We can depending on their determinant is equal to 0 or that is not equal to 0. There are linearly dependent or independent. That is not equal to 0 is dependent. Sorry, independent. And if you have that is equal to 0, they called as a independent of vectors. Like their solutions also we can write into the cross ratio. Cross multiplication ratio test we can using cross multiplication method. Multiplication method we using, and next one you can using into the elementary operations. Elementary operations. Elementary operations. Next or simply we have to do the elimination methods or substitution method or elimination method. Solutions of equations. Substitution method. Those are we have the using into that in this finding the eigenvectors. This method will be using and finding the eigenvectors. So this is the one part of the eigenvalues and eigenvectors in the second module. And also next you learn is the diagonalization of matrices. Diagonalization of matrix. Okay, already you doing this one. And in this first you find any given matrices, you find the eigenvalues and eigenvectors, the corresponding eigenvalues and eigenvectors you find out. And after that, you can make the model matrices. You make the model matrix with the help of eigenvectors, with the help of eigenvectors. So in this different manner we'll be using. Next, third one is the model matrices, and the next one we help of writing to this, writing to the capital D is equal to T inverse and A into P. You find out the P matrix is the model matrix is denoted by the capital P. There we can using into the inverse of matrices. Different methods is there. So your wish. Any method you can find out, but you find the P inverse. I will say that P inverse is equal to writing the dead adjoint P by dead P. So this method we have to using. So if any another sir I have the another method to have, I know that means you can use no problem. So capital D is equal to P inverse into P, and also you can find out the power matrices and write into there, for example, a power of 4 or a power of 10, like whatever have there. So you can write into the like a power of 4 is equal to some example. So that is P into D power of 4 into P inverse. So ఇది ఎలా రాసామన్నది మనం ఆల్రెడీ ఒకసారి క్లాస్ లో డిస్కస్ చేసాము. So find out their multiplication, you get into the diagonalization of the matrices. So this is one method, and the next method, Cayley-Hamilton theorem. Cayley-Hamilton theorem. Hamilton theorem. So you know that the Cayley-Hamilton theorem means if any square matrix satisfying its own characteristic equation. If any square matrices it's satisfying its own characteristic equation, it's called as a Cayley-Hamilton theorem. So here Cayley-Hamilton theorem with verification, you know that it's, for example, you can get the lambda cube minus S1 into lambda square plus S2 into lambda minus S3 is equal to 0. This is some characteristic equation of given matrices. So you write into the if we put lambda is equal to capital A. Okay, so that is we have the a power of 3 minus S1 lambda A square plus S2A minus S3 is equal to 0. So here we have to write in the already A is, you know that, and you can write in the I matrices S3 into I, the same order of unit matrices, and A square, you the matrix multiplication A into A square is equal to A into A, and A cube is equal to, you can write into the A square into A or A into A square. So this has a multiplication you can write into there. So you can get into the some value is equal to 0. They satisfied. You can go for the power matrices and inverse of the matrices. And some properties of eigenvalues is based on the sum of the eigenvalues and the product of the eigenvalues. Okay, if A is a square matrices, their eigenvalues, and you can find out the A is orthogonal. You can find out the orthogonal matrices eigenvalues, like so different problems already we have discussing in these sessions. So if this is in a module 1 and module 2, this completely is a matrices. It's a very easy and very simple topics in this module 1 and module 2. So it's a very important time taking process also is there, diagonalization analysis and Callahan theorems are time taking, but you have the practice is important in this module. Okay, and go for the next module is tomorrow we'll be discussing. That is module 3, several functional several variables and mean value theorems. So these topics you have discussing in the tomorrow. Okay, thank you, ma. Hello.
చెప్పండి సార్.
వినిపిస్తుందా?
వినిపిస్తుంది సార్.
కనీసం సార్.
Tomorrow we'll be discussing into third module.
ఓకే
Okay. ఇప్పటివరకు మనం ఏదైతే నేర్చుకున్నామో ఆ టాపిక్స్ గురించి మాత్రమే డిస్కస్ చేస్తాను. ఇంకేమైనా డౌట్స్ ఉంటే రేపు అడగవచ్చు. ఓకే, మీరు ప్రాక్టీస్ చేశారా?
చేశాం సార్.
ఓకే సార్, చేసాం సార్.
ఎనీ డౌట్స్?
నో సార్.
No. Okay, ma. Fine. Okay, thank you, ma.
ఓకే
థ్యాంక్ యూ సార్. థ్యాంక్ యూ సార్.
సార్ మేము లీవ్ అయిపోవాలన్నా సార్?